The support ticket said, "Why can I see another company's invoices? Nobody was hacked. No credential leaked. No firewall rule was wrong. No attacker was involved at any point." A developer had added a reporting query 6 weeks earlier and left out a single predicate. And every customer running that report had been able to read someone else's data ever since. So let's look at how multi-tenant systems are actually built and why the model most teams choose makes that ticket almost inevitable. There are 3 shapes, and everything else is a variation. Silo gives every tenant their own database. Isolation is close to absolute because a query physically cannot reach another tenant's data, and restoring one customer's backup does not involve the others at all. It is also the most expensive thing on this list, and at 1,000 customers, you are operating 1,000 databases with 1,000 schema migrations every release. Bridge keeps one database and gives each tenant a schema. Cheaper, still separated, and migrations are still per tenant. Pool puts everyone in the same tables with a tenant identifier on every row. It is by far the cheapest to run and the easiest to migrate, because there is one schema and one set of indexes. And it is the one where that support ticket comes from, because in the pooled model, the wall between customers is not a wall. It is a where clause. Look closely at what the pooled model is asking of you. Isolation holds as long as every query that ever touches a tenant table includes the tenant filter. Every query, in every service, written by every developer who will ever work here, including the one debugging something at 6 on a Friday, and including the ad hoc report someone builds in a hurry because a customer asked. That is not a guarantee. It is a hope expressed as a coding standard, and its failure mode is the worst kind because a missing filter does not throw an error. It returns more rows successfully, and the tests pass because the test database has one tenant in it. Code review helps, and it is not sufficient because you're asking a human to notice an absence. The mistake is not that people are careless. It is that the design put the security boundary in the least reliable place available, in the discipline of whoever writes the next query. The fix is to move the boundary somewhere that cannot forget. Row-level security lets you attach a policy to the table itself, so the database silently restricts every query to the current tenant, no matter who wrote it or how. The forgotten predicate now returns the right rows anyway, and the ad hoc report is safe by construction. This is a real improvement, and it introduces a new failure mode you need to know about before you ship it. The policy needs to know the current tenant, and that usually arrives as a variable set on the connection at the start of the request. But your service does not open a connection per request. It borrows one from a pool and gives it back. So if a request sets the tenant and returns the connection without clearing it, the next request can inherit it. And now you have cross-tenant reads driven by pool timing, which is far harder to reproduce than a missing where clause. Set the context inside the transaction and make the reset automatic rather than something each code path remembers. One last thing, and it is the one that catches teams who got everything above right. Tenants are not the same size. Eventually, one customer holds far more data than the rest combined. And in a pooled database, their volume shapes the query plans, the index bloat, and the vacuum schedule for everyone else. The honest answer is usually a hybrid. Pool the long tail and give the few enormous tenants their own database. What makes that survivable is deciding it early, because moving a tenant between models is straightforward if you planned for it and close to a rewrite if you did not. Put the tenant identifier at the front of your primary keys rather than merely alongside them. Keep the tenant lookup in a routing layer instead of hard-coded connection strings, and the migration becomes a data move rather than a redesign. Every one of those decisions has a longer version: how routing actually works, what per-tenant backup and restore involves, and how you keep one customer's traffic from becoming everyone's latency. The multi-tenant SaaS data architecture series builds it properly from the first table onwards. That is where to go next.